This is part 2 of naming ionic compounds. So we'll be basically building upon the stuff we learned in part 1 and now adding on to it. So for those of you who can't see the picture too well, I exploded it. So here's a little ionic compound humor. Go ahead and click pause if you'd like to read up on this. Okay, last segment I had asked you to color this and label this, so you should have this available. If you notice, in the first part we covered a lot of elements that are in the group 1A and 2A elements and a lot of the nonmetals. So those are the only ones we kind of touched in the first part. In the second part, we will now address these ones that I colored in red. The ones in red have more than one oxidation number. That means, like for instance, cobalt could be a +2 or a +3. But before I move on, I want to make sure I address a few specific ones. And one of them is silver. Silver is always going to be a +1, and zinc is always going to be a +2. So on your periodic table somewhere, make sure you label them that this zinc and this silver both only have one charge. Zinc is always a +2, silver is a +1, and the ones in red have more than one charge. So just to show a few examples, compounds with more than one oxidation metal are the ones that are usually found in the transition metals or metals on the right side. So if you notice here, copper can be a +1 or a +2, or chromium can be a +2 or a +3. Iron can be a +2, +3, so on and so forth. Even I haven't even memorized all of them. The ones I do want you to really pay attention though, and to raise a red flag, is when we're starting to deal with mercury. So when you see this, this is a very weird one. Mercury 1 is always going to be written as an Hc2 with a +2 charge, and mercury 2 is going to be written as an Hg and a 2+ charge. I'll get into more detail about this later, but whenever you think of mercury, just make sure you raise a red flag and know that there's a little bit of a trick to it. So let's move on. Okay, so whenever you have a compound that has more than one charge or one oxidation number, we're going to basically put a Roman numeral to let us know what that charge is. So take for example copper CuCl and CuCl2. If you were to name it like we did in part 1, this is how we would write it: copper chloride, copper chloride. But copper has two different charges, and they do behave differently, and it does matter. So like for instance, in the movie Aaron Brockovich, chromium 6 is what can give you cancer, but your body needs chromium 3. So if you ever watch that movie Aaron Brockovich, you'll hear them. That's the whole movie is really about this element called chromium. Anyway, so copper chloride it has more than one charge. So what I have to do is I have to deconstruct this one right here to figure out what the charges on this copper is. So if I look at my periodic table, I know that chlorine is a -1 charge. Well, I have one copper, so I have to the charge on copper has to cancel out to equal 0. So that means that this copper is going to be a +1 charge. +1 -1 equals 0. The way I would write this is copper Roman numeral 1 chloride. So in my second example, I know that chlorine, by looking at my periodic table, is always going to be a -1, but I have two of them. So that means that my total minus charge will be a -2. This copper, I only have one copper, so that has to be a 2+ to cancel out. So +2 -2 equals 0. That's what we want. Net charge of 0. In this example, it's going to be copper Roman numeral 2 chloride. The Roman numeral tells me what the charge is of the metal is. It has nothing to do with the nonmetal. So just remember that this has to be written in the middle between the metal and the nonmetal, and this refers to this. It tells me what the charge on that copper is. So in another example, I have an FeCl3. I know that chlorine is a -1 charge, so that means that the total minus charge is 3-. In iron, well, I only have one iron, so it has to be a plus 3 to cancel out. So in this case, it's going to be iron 3 bromide, Roman numeral 3 bromide. Last example in this set, I know that chlorine is again a minus 1, but I have two of them, so it's going to be a 2 minus. This iron has to be a plus 2. So plus 2 minus 2 equals 0 is what I want. This is going to be iron 2 bromide. So those elements that are colored in the periodic table definitely have more than one oxidation number. It needs a Roman numeral when you label them. So moving on. So a little more challenging ones. I have an Fe2O3. I know that Fe is colored. It has more than one oxidation number. I have to figure out what it is by looking at the oxygen. I know that oxygen has a minus 2 charge. So that means that if oxygen is minus 2 and oxygen there's 3 of them, that means I have a total of 6 minus. Well, I need to have a 6 plus on this side. I have 2 irons that needs that total up to be a plus 6. So that means that for each iron it has to be a plus 3 to cancel out. 3 times 2 is 6. 2 times 3 is 6. That means in this one it's going to be iron 3 oxide. Okay, moving on to the other one. Chlorine has 6 of them here, and I know that each chlorine is a 1 minus, so that this has to be a 6 minus on the bottom. Well, that means that this iron has to be a plus 6 to balance out. So that means I have to write a Roman numeral Vi. So that means it's iron 6 chloride. So that lets me know that it's an iron 6. Okay, now we got mercuries, and this is definitely going to be a red flag. So we know that I know that chlorine is a minus 1 or 1 minus, but I have 2 of them. So that means that my total minus charge is a minus 2. That means I have to have a 2 plus charge on this side. But I have 2 mercuries. So that means I know that each mercury is going to be a 1 plus. So this is going to be a mercury 1 chloride. The unique thing, and let me highlight this and emphasize this, is that mercury 1 always has to be written. Mercury 1 always has to be written with 2 mercuries, Hg2. It can never be written as a by itself. You can never have this, for example, HgCl. That can never exist. Mercury 1 chloride. Mercury 1 always needs that subscript 2 to be valid, and you would have to write it like this, just like we wrote before. Okay, on the next one, we know that oxygen, let me erase this. We know that oxygen is a 2 minus, and well, mercury here has to be a 2 plus. So this is going to be mercury 2 oxide. So mercury 2 is okay, it's typical of everything else. It's just that mercury 1, you have to be careful in how you're writing that. Alright. Now, when we work, where were we? Backwards, it's actually a lot easier. So we have tin 2 bromide. The symbol for tin is SN. Tin in this case has a 2 plus charge because that's what the Roman numeral tells me. Bromine has a minus 1 charge. Well, that means I need 2 bromines to cancel out that 1 tin. So I would write this as tin. SnBr2 is how I would write this. This tin 4 has a 4 plus charge because that's the Roman numeral. It tells me what the charge on the metal. Chlorine is always going to be a minus 1. I need 4 chlorines to balance out that 1 tin, so I write it as SnCl4. We do not write any Roman numerals when we balance out the compounds. We only use Roman numerals in the names. We have lead 3 fluoride, so I know that lead is Pb. It's got a 3 plus charge. Fluorine is a minus 1 charge. So I need 3 fluorines to balance out that 1 lead, PbF3. So that's correct. Okay, I have iron here. Iron is a symbol Fe. I know that iron has to have a 3 plus charge because that's what the Roman numeral tells me. Oxygen is a 2 minus. And here we got this weird one where one's a plus 3 and one's a minus 2. I have to get the lowest common denominator, which is 6. So my answer is going to be Fe2O3. So that's how I write that one out. Okay, last slide. Okay, magnesium bromide. How would you write that one out? Well, this one's a little bit of a curveball. Magnesium has no Roman numeral, and it doesn't because it's not colored. We know that magnesium is always a plus 2. And bromine is a minus 1. So this goes back to the first segment of our podcast. And we just write this as MgBr2. So now we're starting to get incorporating both parts in naming compounds. Okay, lead 6 oxide. I know that lead symbol for lead is this. I know what the charge is because it tells me right there, the Roman numeral. And I know that oxygen is a 2 minus. And I have to get them set to equal to 0. So that means I need 2 more oxygens to balance out. So the way I would write this is PbO3. So PbO3 would be the correct answer. Cobalt 2 nitride. Cobalt is going to be, symbol is plus CO. Charge is going to be a 2 plus because that's what it tells me. Nitrogen, symbol N, and it's got a charge of 3 minus. And again, it's an uneven number. Lowest common multiple is 6. It's going to be CO 3 N2. That's how I write cobalt 2 nitride. And the very last one, mercury 1. Here's my trick. I always have to write mercury 1 as an Hg subscript 2 with a 2 plus charge. Always, whenever I see mercury 1. I know that oxygen is a 2 minus. Well, since they cancel each other out, it's going to be Hg2O. Alright, so that concludes naming ionic compounds part 2.